So hello everybody. My name is Violeta Montoya. I'm a PhD student in urban hydrology in the Environment and Pollution Laboratory here in Lyon. And today I have the honor of presenting with Hervé Caltran from the Metropolitan Authority in Lyon. I don't know whether you want to introduce yourself. Yes, Hervé Caltran. I work for the Metropolitan Authority in Lyon in one of the departments called the Water Cycle Department, where we manage all problems, sanitation, so cleaning rivers and things like that. I'm going to give you the context first, and then I'm going to hand over to Hervé Caltran, who will talk to you about projects organized by the Metropolitan Authority in Lyon. And my thesis focuses on rainwater. In most European cities, we have got a combined system for rainwater and wastewater in the same pipe. And when the flow rate is high, for example, when there's a lot of rain, the system has to be relieved. And there are hydraulic systems, for example, storm overflows that can be used for relieving the system so that the water, the urban water, can be discharged into the receiving environment. And that water is highly polluted. So it's wastewater without any treatment, and the rainwater we know today is also polluted because it's got all of the surface washout, and it has a very high level of concentrated pollution. And this can cause damage to the receiving environment, for example, eutrophication, among other things. It's a management system that is not good enough given today's problems, given urban development, the increase in population, and with climate change, where we're seeing an increase of extreme events. And so we're facing some big challenges today. And today there are other possibilities, other opportunities, for example, integrated urban water management, so that wastewater and rainwater is sent to the wastewater treatment center. So instead of having the combined system, we can have alternative systems throughout the catchment area so that we can retain and filter the rainwater and see what we have in the sewage system and reduce the overflow. So instead of having the funnel effect, everything going into the same pipe, we will have something that's based on percolation and filtering. So instead of having a sponge that absorbs everything. So we've got different types of systems, source-based management systems. We've got rain gardens. We've got other systems. For example, we can have more greenery in the city, more biodiversity in the city, and we can reduce the risk of flooding. So I'm now going to hand over to Hervé Caltran, who is going to tell us about the project organised by the Metropolitan Authority. Yes, I'm going to just present some examples of what we're doing in the city. So the Metropolitan Authority covers 59 municipalities, and we've got a local authority with different skills, different powers, especially when it comes to urban development and quality of life. And this is where you find water management and waste management. So the Metropolitan Authority is an authority that has networks that are mainly combined networks with all of the drawbacks that Violeta mentioned. It's a local authority that for 40 years now has focused very much on getting rid of impermeability and disconnecting wastewater from rainwater. So how do we do this? Well, for 40 years now, we've been focusing on this question. To begin with, we had big basins, as you can see on the right-hand side of the screen, big basins that were mainly they had a high mineral level, and then little by little, this big basin was changed towards something with a lot more greenery in it. And then we used a more source-based and decentralized management with filtration systems. This is what you can see in the middle. Today we have about 40 or so kilometers of filtration dikes and rain gardens. That's what you can see in the middle, the bottom slide, with swales that have vegetation in them. So all of these source-based systems are very advantageous when you want to disconnect rainwater from wastewater, because in the peripheral areas, this is good, but also in cities when you're demolishing several hectares in the city and you've got spaces to put in place these structures. But when you're interested in managing rainwater in urban centres and historic centres where there are no big urban projects, it's much more difficult to manage rainwater. And the authority decided to focus on rain trees. So these are solutions based on nature itself. So these rain trees, well, how did they come about? Well, it's based on observations of trees in cities. So, for example, this is what you see on the right-hand side. There's a type of tree that you have in the city, but that you can find in other cities and towns across France and Europe. These are trees that are in a specific environment that is hostile and aggressive. They've got no space. They're quite limited. And on top of the hostility, the trees suffer from water stress, given the climate change that we're going through. So they suffer from water stress and the hydraulic functions that we expect from them, so that they've got to improve water filtration and help via evapotranspiration. Well, these functions are no longer fulfilled. If you look on the left-hand side at the photos there, so we've got willows. The only people, with their feet in the water are the people walking. So that's because our cities have become so impermeable. And so it's based on this observation that we took part in a project promoted by the Biodiversity Office, where there was this focus on rain trees. So the idea is to take a tree that already exists, to work on it, to remove the impermeability, to make sure that it has more space around its roots. So we dig around it and we add topsoil, and then we create an infiltration dike near a water course, and we reduce the height of the pavement. So we reduce the height of the pavement, and that's so that the water can come into the filtration dikes. The objective is to adapt to climate change and to fight against urban heat islands, and also to fight against flooding and runoff, to work on biodiversity, because it involves replanting greenery and improving the living environment. Is it going to work? Well, to measure the efficiency, we instrumented the trees and the dikes, so the infiltration dikes, to see whether they overflowed or not. So we inserted tensiometers in the soil around the tree to measure the humidity of the soil, and we installed micro andometers on the tree. So I haven't got time to explain to you exactly what we observed, but if you look at the first graph on the right-hand side, we started to measure the overflow of the infiltration trenches. So 5 trees were planted in line along a street, and they were so we followed them from spring to the next year. We looked at whether the first trench overflowed, and whether that meant that the 5th trench overflowed. So that would tell us whether we could manage all of the rains. So there wasn't that much rain, but we were able to manage the rain that fell. So we also wanted to look at less hostile spaces, and with andrometry we looked at trees that were redeveloped as rain trees. So their growth is much bigger than the witness trees that weren't treated in the same way. So there is a local effect. This was proven. And the question that we are asking today is, are we going to have this effect for the whole sewerage system, for the whole network? And how can we optimize things from a local point of view? But now I'm going to hand over to Violeta. Thank you, Hervé. Thank you for introducing the project of my PhD. So managing source management of rainwater is all well and good, but strategic management is even better. And that's why Tonic came about. The idea was to provide a decision-making tool to help with authorities so that they could manage urban waters. So it's made up of 3 areas. The first is the development of a tool for optimizing the degree of disconnection. In other words, to know where you can act as a priority to reduce overflows. The second idea then is to develop a tool for choosing the right technology. And the third is to study the consequences of what you set up that is based on source management. So my thesis focuses on the development of this tool for optimizing the degree of disconnection between wastewater and rainwater. In my thesis, I'm going to work on a 3-stage method. The first is to identify the area that is going to contribute to the overflow system and to break that area up into different sub-basins in order to identify the sub-basin that contributes most to the overflow. As part of the second stage, I'm going to establish a hydrological and hydraulic model that is simplified so that I can quantify the flows, the overflows. And this will give indicators that tell me about the frequency of overflows on a yearly basis. And with this system, it will be possible to identify areas to be disconnected and the systems. So this tool was developed based on the Écully watershed. So we know the flow rate, we know the precipitation level. So we've got data from the Othu. So based on several years of observations. So to develop the hydrological model, what did we do? Well, we've got to look at rainwater, precipitation, we've got to know the flow rate, and from the data, we've got to be able to set parameters so that we can simulate the runoff water, the wastewater, and the parasite water that infiltrates into the permeable surface and that then percolates down to the sewage system. So these flows are then transported in the network with a simple model, which is a linear network. And then that makes it possible to make sure that the water goes down to the storm overflow and then is discharged. And that will give us the indicators in terms of the overflow frequency and the volumes discharged. So this is the result based on the simulation of a rainwater event. We can look at the different components. The rainwater component, for example, which is in light blue, that produces surface runoff and the permeable and impermeable areas and goes into the system. We've got the wastewater component, that's brown, and we've got the clear water for events and on clear water on a permanent basis. And then we've got the model of our overflow with the threshold for the overflow, and we've got a comparison with observations in black. So for 2007, the model forecasts 7 out of 26, and that's similar for 2008, 9 and 10. So the objective is to test the model over several years so that it's possible to determine its performance level. So the model is going to make it possible to quantify the contribution of each component to the overflow volume and to know what volume is produced in each sub-basin and to know what the volume produced is by each component in order to determine the sub-basin where we need to focus on and what the component is that we need to act on. Now, as we don't have much time, I'm going to conclude with the prospects for this thesis. We want to explore how we can model complex storm overflows, because not all stormwater overflows are the same. We want to establish a method for identifying priority subbasins so that we can focus our source-based management on those. And we want to look at other models like Vernet and Fujac with different data. Because we don't have much data available. So we want to see how the model can respond to those cases. So thank you very much for your attention. Thank you, Violeta and Hervé. Are there any questions? Thank you very much for your presentation. I want to know two things. For the Metropolitan Authority in Lyon and the adaptation of the city so that it's a kind of a sponge city, how long will you know what the quantities are, and what are your specific objectives? So I can't really tell you how long it will take. With respect to the objectives, well, they are set by the Water Framework Directive, so taking us through to 2027. So we haven't got much time left. And then there are objectives set with respect to the disconnection and the removal of impermeable areas. So with respect to de-impermeabilization, this is done automatically with regulations and the local urban program, because we impose zero discharge of rainwater in the combined network, unless there's an exception, but there are very few of those, for the public space. And so for that public space that's not subjected to the program, where you have 4,000 hectares to be de-impermeabilized, the big question is it going to work? Well, we don't have any scientific data to prove that yet, and that's why Violeta's work is very important. So I also have a question for Violeta. So in your model, what is the acceptability level for overflows? Well, you know, how many millimeters of water is acceptable? So, given the case study that I'm studying at the moment, I've observed that overflows take place when you have rain of a height of over 20 millimeters. But not all sewage systems and overflow systems are the same. Some are more sensitive than others. Some overflow with a very small volume of rain. So in that case, you know, if all of the water is infiltrated, then so all the water below that height, we know that we're going to reduce the overflow. So the study of available data and observations are used to determine the strategies that will be used for the basin in question. If I can just add something, just to give you an idea of the number of overflows in Lyon, it's over 2,000 stormwater overflow systems. Some actually overflow when it's dry, so that just gives you an idea. And that's also the case for many small cities that overflow when, the weather is dry. So it's not just about managing rainwater, it's about managing these stormwater overflow systems generally. So the first site that you focused on, you used the OTHU data. Are you then going to go to other areas in Vernet and Figeac where there is less data? What about other OTHU sites that have a different hydrological functioning system? Wouldn't they be good to test your model with long-term data, for example, that might have been produced? I'm just going to add with what I know about OTHU. There's the watershed of the Iséran, but it's a very urban basin, and we're interested in urban basins, and that's why we focus on Écully. And then there's the Figeac catchment area. So Figeac has a lot of problems, and that's why it's interesting to study. And it's currently focusing on its urban plan for managing urban water. Thank you for your presentation. I have a question, but perhaps it's a bit broader. It relates to the disconnection of the rainwater and source infiltration. In the future, do you want to look at the impact on the on groundwater and how it is, how the water table is filled up? So this was the idea with this source-based management. The OTHU has instrumented large basins. These basins concentrate much of the runoff water and therefore many pollutants that have high flow rates and high levels of concentration. And the monitoring of the water table based on the OTHU shows that there's no transfer of some of the pollutants, so the PAHs and heavy metals, for example. So that means that the resource is protected. But then there are other projects, micro projects, are focusing on source-based systems that help us to feel more serene when it comes to conserving the water table. So we're using the results of research in order to make progress in what we do. So it's a problem of quantity then. So you've got rainwater, and then you've got a source-based system, you've got micromegas. It shows that it's very difficult to estimate the quantities, in fact. Yes, it's difficult to quantify, but micromegas, it shows that we don't have too much pollution. And then there are projects where basins have been instrumented, systems have been instrumented, and tests have been set up for monitoring purposes. In fact, you've got the problem of quality, but also the problem of quantity. So I think that's what Florian's question is about, really. So basically, we're completely changing water flows. What's going to go into the water table? What's going to go into the river from surface runoff? Are we going to be absorbing everything? No, we're not. Even if we're turning our city into a sponge. So there are lots of questions. How is it all going to work from an environmental point of view? So often the question is raised about the fact that we're in the center of Lyon, and if we don't find them in our groundwater, it will be in the wastewater treatment centres. So the pollution will always be there. That's the first remark. The second is that it's important to conserve the water table. Nobody is pumping water directly below the city of Lyon for potable water supplies. Even if the water table may be polluted, what's going to happen? The pollutants will leave with the water table and they will find themselves in the aquatic environment, in water courses. And that's what's happening now with the stormwater overflow systems. So, we don't really know which is the best solution, one or the other. These are interesting questions indeed, interesting things to explore. And that's where we're finding it difficult to provide an answer. You know, we don't have enough scientific data for the moment.
So for a systems approach, this is for Violeta, the optimization requires some understanding of what the constraints are. So for example, pollutants, it could be that you would want to minimize the amount of certain pollutants over others across the system, and the constraints are what is allowed to be controlled in different regions. So can you say something about what the constraints are in your optimization aspects of the systems tool?
Merci pour la question.
Thank you for that very interesting question. Yes, I didn't talk about this. It's true. So the optimization method, in other words, focusing on which basin do we need to focus on? Well, it really depends on regulations. So since 2015, regulations mean that we have to focus on overflows. We need to focus on the volume, the quantity of pollutants that overflow. And so we're going to focus on frequency and volume. So this is how we're going to know what effort needs to be applied to these basins so that we know, so that we're in line with the regulations.
Can I follow up? I understand that, but the constraints are, for example, Hervé, the amount of money that is available to invest in rain trees, for example. There's a constraint on how much funding is available, and that's an external constraint, and it might be different in different subcatchments. Is there anything like that in your perspective?
No.
No, I don't deal with economic constraints. These are things that are dealt with through other projects. So where they quantify things from an economic point of view, they look at what's decentralized or whether the sewerage system should be extended. Thank you very much, Violeta and Hervé.